You all know why you're here. So having said that, I'm going to make a very, very brief introduction. Then I have to dash off to yet another meeting and then go to be installed as dean, but I'm delighted to do this today. This is extraordinarily important, and we are extraordinarily delighted that Mr. Berners-Lee has joined us today for this presentation. You all know the scope of his work. Let me just say very briefly that he is now the director of the World Wide Web Consortium. He is, in the short term, the inventor with a handful of colleagues of the World Wide Web that we all take for granted today. He's a graduate of Oxford University and holds the 3Com Founders Chair and is a senior research scientist at the Laboratory for Computer Science and Artificial Intelligence at an institution called MIT. I think some people heard that and you have the affiliation. He is co-director of the new Web Science Research Initiative, which is very, very interesting. He will tell you more about it. And we certainly hope that here at the Annenberg Schools for Communication that we will have an opportunity to be more and more engaged with the work that he is doing over the coming years. And with that, let me welcome Tim here. It's a delight to have you here on campus and at the Annenberg School, and the floor, sir, is yours.
All right. Okay, thanks very much.
Thanks, guys. Good to be in touch.
Okay. Well, it's really great to be invited, and also to be able to participate in the things we were doing this morning. Thanks for the introduction, even though you're not really dean yet at all, until this afternoon. But but thanks anyway. Sorry. So I'm going to look back at the past a bit about the doing the web thing, which was largely about and the message which I have when I give this talk to technical people is, you know what, the social aspect of it is really important too. So that's the theme which runs through it, which for you is probably in the category of duh, and so you might want to look at it from the other point of view, but the importance of the two being very connected, and particularly when, of course, the problem I had when doing the web, inventing the web was something actually fairly straightforward. It was the sort of thing you can do on the end of it, back an envelope and code up in 2 months. Persuading people that it would be a good idea, helping getting over all their misunderstandings about what it was supposed to be, was very much more difficult. So I'll go back over that, and I'm not just going back for the sake of reminiscing about history. I'm going back because right now, of course, we're in the position where there's a whole lot of stuff to come. And in fact, we're a little bit worried that we're not really doing research. Way back when I went to MIT, started the World Wide Web Consortium, and a member of the faculty came to me and he said, something I wanted to ask you, Tim. As one of the networking people at MIT, why didn't we develop it here? and I thought it was a... but it wasn't a silly question. He really wanted to know, and in fact, looking back, I thought, nobody was actually trying to look that far out. Nobody was trying to, think of what was possible. They were moving incrementally, and so there was no place where I really could have produced the. Nowhere where I'd have been where I could have joined a group that was doing inventing webs and things. So we're saying that we should now not fall into that trap again, and we should look forward, do research around this thing which is called the web. So I'm going to start off by looking back before the web, and then we'll move on to web science. The funny thing is now that particularly in an audience like this with mixed ages and colors of hair, we find that some of the younger people actually find it difficult to know to think back what it was like before the web. Some of the very younger ones weren't there at all. But because it was a paradigm shift, the difficulty of explaining the web in the first place was that we didn't have vocabulary like link and click. So I could show somebody a web page, and I did. I wrote a web browser and show people a web page and click on it, and ta-da! Another window would open with a different web page. So what? No big deal. So like hypercard or something. Yeah, hypertext. We've seen that. It was a sort of that was a sort of a fad for HyperCard, wasn't there, and hypertext and things like that a few years ago. Whatever happened to that? What they couldn't understand was what was really interesting about this link was that this one could have gone anywhere to any data you could imagine being out there, and conceivably interesting. The fact that now pretty much anything you can imagine being existing out there, it's got a high chance of being on the web, and that the fact that that link could have been there was just really difficult for people to understand. And but what would happen is I would give a talk. I wouldn't have this many people in the room. But if I had some phrase, well, maybe I would have, if I gave a talk at CERN about a new documentation system, and I went to plenty of talks about people proposing new documentation systems, and if I did talk about it, then maybe 3 people would go through the mental extrapolating process, extrapolating to infinity, and thinking, just supposing everybody else did this. And there's a certain sort of person where when they're in a situation that if everybody did this, it will be really, really cool, they will do it, just because of that. So the 3 people would go off and do it, and I'd maybe get an email back from them saying that they downloaded the early web server code, and they downloaded it from the FTP server on my desktop machine. They'd read about it on the web server on my desktop machine, and they had set up another web server, and they sent me the address of it. And they would sometimes put in, some photographs they'd taken, or they would put up some. In the early days, the first ones were all text. We just didn't have images and web pages, but and all kinds of things. Some of them were in high-energy physics. Some of them were people excited about hypertext. And then I'd put them on the list. And I got a copy of that list of all the web servers when there were 26 on it. So I didn't keep track of the whole list. Of course, one of the reasons the web scales is there ain't no central list. If there was, somebody would try to control it, and that would limit the spread of the web, and people would be then making a central another one. So decentralization is really important. So now, so it was difficult to explain what the web was like now. Well, what the web was going to be like then, but now it's difficult to explain why it was difficult to explain that. The environment I was in was pretty nice from the skiing point of view. There's Mont Blanc in the background, the Alps, the French and Swiss Alps, and in front of us, in fact, there's the lake is Lac Léman with Geneva at the end. There's Switzerland is just around Geneva, but on the other side of the lake, and also around below us is France, and this is the big accelerator, which is hundreds of feet underground. But the particles go around inside that tunnel in a little tube like that. In fact, they're turning on a new accelerator about now. So it's exciting times at CERN again. And a few places, some of the marked places around the ring, when you go down hundreds of meters underground, you find a detector, which is a huge piece of electronics. And interesting about it from the web point of view is this was created by lots of people coming from different universities, collaborating and building the BICs at home, and then shipping them and hoping they would plug together. They spoke different languages. They used different sorts of computer. The computers ran different sorts of operating systems. And of course, the documentation they wrote, when on a good day they wrote in completely different languages. In general, people have to record how they do something, so there is always documentation. But at CERN, it was in the pre-web days, you would have to go to a particular machine, which you'd have to be told about in the corridor. You would have to log on to that machine. You would have to find out how to use the particular program that was used for that particular type of documentation. And then you could find your way through it, through the library system, through the manual system, whatever it was, to find something, and then you could, with a bit of luck, maybe get it back onto your computer. And then you had you have to be very lucky if it actually turned out that it was in a format you could actually read. So when you have so many people working together, particularly academics, academics who won't be told by CERN, work at your home institute for 3/4 of the year and then come to CERN, and then when you come to CERN, you must use this operating system and this machine. That wasn't going to work. So no, when they come to CERN, they bring all kinds of interesting things. That's what made the place really, one of the things that made it a really exciting place to work, that diversity. So there are people from all over the world, very diverse sets of information, and the web had to bridge that. Actually, I'm going to flash back 10 years, because I actually first met CERN as a contract programmer. I went in there, just flew in there with a bunch of cowboy-style contract programmers, came in for 6 months to try and fix a project that was late. The PSB vacuum control system was part of it. That was the bit I was involved in. And I wrote this program. This is Inquire. It just runs on a, as you can see, an 80-column screen with 24 lines. And it didn't have any graphics because it was just a green phosphorus screen in those days. And you could navigate between these various note cards. This is a note card about the vacuum control system. There'd normally be a bit of text in there as well. And you could edit the text. You could type commands in the bottom, or you could type a number and go to something related. And the rule was you could only make a new note card by typing in it as a link, by linking it to an old note card. So everything had to be connected. So you had to be able to find stuff. But you could make it into a cross-linked web as well as a tree. So that was fun. Just point out two things. One is it's capturing the semantics of the links, described by or includes. What I wanted to do with this program was make it so that it was really easy for me to track the bits, the things that machines I was working with. I also wanted to sort of capture in those is part of relationships the org chart effectively of CERN. I wanted to capture the structures of the machines and the way and I wanted to capture the dependencies between software. So the idea was that if everybody used the software, then after a while we'd get this map. And we'd start to, and particularly for the dependencies, for example, I'd like to be able to say, okay, suppose we pull this piece out, or suppose this person leaves. Then, what have they written? What have they written that's not documented? What programs are running which depend on the modules that they have written, and which pieces of hardware are going to collapse or catch fire if those programs start working? So tracing back through the dependencies of the network I thought would be something which would be really interesting. I wrote a little five-page manual about this, and the last paragraph said how interesting that would be. But it was basically, I suppose, the semantic web in 1980. But the program in its initial form was on an 18-inch floppy disk, which is probably not it's probably been completely lost, or somewhere, or maybe it's still in the cupboard. And I sort of dream sometimes of finding it, and probably would be very disappointed how boring the program is. I rewrote it a couple of times, but basically it disappeared. So 9 years later, I'm back at CERN. I came back as a fellow. I ended up as a staff member. I'm doing software engineering again, and it's a similar situation. Computers have moved on. We've got Windows, we've got mice, we've got pointers, and I still feel we need to make a documentation system which will encompass all the other ones. Rather than just writing my own system now, I'm really looking at the problem of interoperability between the different ones. And I'd written some programs to pull stuff out of the IBM mainframe and put it onto a VAX, to convert it out of the IBM documentation system and make it available as a VMS help file. And when you do that sort of thing, when you convert between different formats, you start to realize, especially if you've been trained as a physicist, you generalize. You think, hey, there's got to be a general rule here. And you realize all these systems, even whether you go through menus or you basically all the human interaction consists of selecting from things, basically following a link to another position, or sometimes typing something in. So the first web browser allowed you to follow a link, or under certain circumstances, type in basically something into a search bar. So it was a generalization. This was the idea, and I wrote this in 1989 because somebody said, a colleague said, hey, Nick, why not write that up? But there was nowhere to send it because CERN is a physics place. It's not a software place. No committee there for me to go and send it off to. So nothing happened. In fact, there was a party later on where I met somebody, one of the original people I'd sent this to, and he said, oh, what happened about that hypertext idea you had, Tim? Well, I actually sent you a memo about it. Oh, you did? Could you send it again? So I sent it again, and I wrote at the top, March 1989, comma, March 1990, just to rub it in. This is not the first time you've seen this. And sent it around to a whole bunch of people, but the same thing. Nothing happened really. However, my boss, Mike Sendel, guy I was working for, and a nice guy with a twinkle in his eye, he noted September of 90, I guess it was, that I'd always, that this next box had come out, and I was kind of keen on getting it. I was getting interested in getting into Unix instead of the VAX VMS machine I was using. And the next machine had all kinds of nifty gadgets on it. It had the DSP, it had the optical drives, not to mention the magnesium cube. So he said, and we were in a lull between two accelerators. So it's sort of, we were allowed to take a breath at that point. So he said, why don't you buy a couple of those next machines? And why didn't you kick the tires? You know, they're supposed to be really good development platforms. One of the things they had was the interface builder software. You know, it's ironic that a lot of the software which was on that is in OS 10 now, all these years on. And it had this interface builder software which makes it really easy to produce an application study from. Not very much. And he said, why don't you, we should evaluate it as a development platform. We'll need some kind of play program, just some random project. How, you know, like that hypertext thing. Why don't you just do that? Check it out. So I got the computer out of its box and fired it up and started up the interface builder, and it said file, new project name, World Wide Web. Well, actually, I talked to a few people about it and rejected some other alternatives, but that was where the first place it got written in was worldwideweb.app, was the World Wide Web application. And Mike, alas, is no longer with us. He contracted a nasty bone cancer about at that time and died several years later. But among his things in his desk was found a copy of this memo, and in the top corner in his writing and pencil are the words, vague but exciting. So, you know, I treasure that. And that's probably what he said to me. But the main thing is he didn't say don't do it. He let me go and do it. So I coded it up. Nobody breathing down my neck. No standards committees. No, I just kind of coded it up and then wrote down a little document about how the UDIs, as they were called, worked, and you know, how the HTTP protocol worked, and the HTML language, which are all fairly straightforward copies of sort of adaptations of other protocols which are out there. But the important thing which was went behind that design was the universality. So, you know, if you go away today with any one thing in your head, when it comes to the web architecture, it's that it is a universal space. It's got to remain. It's got to be there like a white piece of paper for people to do other stuff on it. And the web is great because of all the things all the creativity which other people put in. It's universal. It mustn't control what people want to do with it. It's got to be able to work on any hardware platform. There were plenty of documentation systems which people proposed to CERN, which they would explain, this could take all the documents, this could solve all our documentation problems on all the systems throughout CERN. All you have to do is to code your document up in HTML and store it on the mainframe. And you know, what's the problem? You don't want to use HTML? You don't want to use the mainframe? Oh, sorry. So the next week, somebody's presenting a proposal to do it with Max and Word. And so every time somebody tries to persuade you to use this particular hardware or a particular software, that wasn't going to fly. So this has to be a system. It's an abstract system. It should be independent of the hardware and the software. Also, it had to be independent of the way you think. A lot of those systems, they lost traction because they told you that you had to put your documents into projects, and the projects you had projects and categories, and they were a matrix. You could think about categories which would apply to all your projects. And other people would have just like a tree structure. And you know, when you do that, you're trying to get people how to think, how to organize their life. And that's on the web. I couldn't do that because some people like to do their work in trees, and some people's work, you know, doesn't fall into matrices. Some people's work does. Some people like to think one way, some people like to think the other way. The essence of this was to be a universal space, and the great thing about hypertext pages is you can arrange them into any darn shape you like. And a lot of the problems that people would bring up was a fear that this will be just one huge tangle and everybody will be lost. Now, I had to explain to them, yes, I know it's potentially a tangled web, but within your space, you can organize it in a matrix. You can organize it in a tree. So, universal in the sense that in all these dimensions, it shouldn't dictate. One of the important ones is I wanted to be able to use it for a scribbled note as well as a published paper. In fact, I was really interested in the process by which the scribbled note becomes the published paper. I was a software engineer. I was collaborating with people in different labs that I would only see a couple of times a year for short periods of time. So I'd have students who would come in, have the summer. I'd have to get up to speed. I wanted them to be able to go into the web, get up to speed, design with me in the web. I wanted us to build, in our meetings on and offline, I wanted us to build the web as a collaborative design so that we would always leave pointers back to why we made decisions. Would always be pointers back to the documents we read when we had a meeting. And so that somebody coming in will be able to understand. Somebody who's going to reverse a design decision was made can find out why it was made, find out what they're going to damage. And also, when they leave, they don't have to do the big debrief and explain to everybody what they've done, because it's there. They've been woven it into the group, woven it into CERN, woven it into whatever size of group they're using. So that was the plan. And so the first web browser was an editor. It was designed really to be a collaborative thing. If you could had write access to a page, you could just correct a spelling mistake, hit save. You could highlight a page, one page. You could and hit mark, and you could highlight another page and hit link, and the marked text will be linked with a linked one. We'll go from the L to the M, just like that, and hit save all, and all the pages would get saved back. So that was the tool that I wanted to use, and I wanted to use it as a collaborative play space. And the web, of course, as you know, took off very much as a publication medium, and we can all philosophize about why that was. One of the reasons, though, was that HTML became more complicated. So designing an editor, just the people who were writing editors got left behind, which is kind of ironic, because now when you look at the way people can now create on the web with a blog, is that they can use a really crude form of hypertext. The sorts of thing you put into wikis and blogs is like the original, very close to the original HTML, nothing very sophisticated about it. So we went too complicated in the language for the writing, and we should have forked it into two pieces, I think. So this is so that then the web took off. This is the hits on our server. Okay, this is people hit page loads per day. This is the first server, and in July of 1991. This you see it starts at the scale, the log scale on the left. It starts at 1. Other people later on didn't put the other web servers didn't start at 1, but in those days this was the first one. And so it was basically started off around 10. But what is interesting about this graph? There are a number of interesting things about this. Of course, as you're all social scientists, you'll recognize as a straight line. I have a hard time with the mathematicians and physicists, but you'll see that it's in fact remarkably straight for exponential growth. This is really, in a way, almost spooky, that every year I would look at the length of the log, and it would be 10 times the length of the log from the 12 months before, regularly 10 times over each year. So why did it keep pretty much? You can see there's some times when the server went down or we lost the logs. And it had this also a big gap down the middle. There were two lines there with a gap down the middle. So I asked the student who produced the graph, analyzed the logs, to color it by days of the week. And it turns out that the weekday hits were always a certain proportion above the weekend hits. Now, but obviously at the early on, you'd think that this was a few of my friends who were hitting the website. Later on, it was becoming a movement. And in between, you'd think the readership would have changed, but the ratio between the week and weekend hits just stayed the same through these 3 orders of magnitude, and it kept exponential. And of course, so that was the rate of load on our server. That was, of course, just one server. That was meanwhile, the number of servers was exploding as well. Some of them loaded a whole lot more than this, so this was just the server about the World Wide Web project, basically. It was. While that was happening, people always ask, so I might as well answer it now. So when did you realize that it was going to? When did you realize it was a success? When did you stop worrying that it might fail? And the answer was, still haven't. I still worried about it. Then there were lots of graphs that go exponentially up and then drop off. That happened to the Gopher system from the University of Minnesota, very web-like thing. It was way more popular than the web, tricking off exponentially with, I think, maybe a sharper times constant. The University of Minnesota then announced that, by the way, they might be licensing the material. You might have to pay royalties. They were toast overnight, and people were putting a huge amount of pressure on me to get something from CERN, and CERN, to their huge credit, did produce 18 months later, after a lot of pushing by my colleague Robert Caillou, a document which declared that CERN would not be charging royalties on the World Wide Web, and that is why it happened. That's why it took off very largely. So it was, however, taking off to the point that people eventually came to see me to explain that they wanted to be involved in its future. And particularly Alan Kotok from Digital Equipment came to me and he said, I'm part of a strategic vision task force, and we've decided we should retool and reorganize digital equipment completely around this web thing. And I gather that the specs are sitting on your desk somewhere. How do we get involved in the review loop? How do we get involved in making the web better and smarter and and check that it's stable? And I asked him what he thought was a good idea, and he'd been very involved in the X consortium, so he said, do that, go to MIT, get them to start a consortium like the X consortium. MIT, turns out, we're happy to do that. And so I think there was a critical time. Anybody here done bobsled? I've never have either, but it looks as though there's a point where there's a phase at the beginning of bobsled run when you're pushing. The whole team is pushing, and it's really hard because the bobsled has in fact got some inertia. And then it picks up speed. And the later phase, you're all in the bobsled steering and things like that. And there's a very important transition phase when you stop pushing and jump in. And for the web, that was about 1993. And if you don't, if you miss that, then you have the bobsled has problems. So I was concerned in 1993 and started rushing around talking to people about what sort of consortium we do. And eventually, the result was the World Wide Web Consortium, and that has been running, constantly changing itself, constantly re-examining how its process works, because the web and the society around it, the things it's trying to do, have diversified and have evolved and morphed, but it's still going strong and producing lots of and being the place where the standards both evolve and also we produce completely new technologies. That was in 1994. The whole spirit of that age was wonderful. The most interesting thing about it actually was not connecting all these documents together with links. It was working with all these wacky people. It was working with those three people who went off with a twinkle in their eye and figured, hey, it would be kind of cool to write a new web browser or write a new web server. It was meeting them at the first web conference later when we'd only communicated by email and finding that they had faces or as diverse as their opinions online. And just the whole spirit of it was a completely volunteer force. Almost without exception, these people who did push the web forward through the first few years did it without their management consent, very often knowledge, and perhaps understanding of what it was actually they were doing. One of my favorites was Kevin Hughes at the University of Hawaii. I don't think he asked the University of Hawaii whether they wanted a dinosaur exhibit. He just thought it would be cool, and he put all this dinosaur museum up on the web. And I don't think he's gone now, but the deans actually, when they were congratulating the whole way on the dinosaur exhibit that the University of Hawaii had, understood what it was all about. But because it was just some guy, Kevin was maintaining one of the systems, I think. I'm not sure what his function was, but what the result was for the world was that the University of Hawaii had a dinosaur exhibit. There are all kinds of wacky things, and that was really fun, and it still is. We're doing different things. We moved on, but in a way, but there's still very much the same spirit. So the Web Consortium we found in 1994. That's when I came to the States. I found I had to really, the internet was much further deployed in the States, so the thing really took off much more rapidly in the States over the existing internet. Now, 2006, and at MIT and also with Southampton, we're looking at web science. So the rest of I'm going to talk about web science, but not before we've looked at a map, because I was giving one of these talks, and somebody introduced, I read just before I went to do the talk that somebody had put into the program that I was going to present a roadmap of the web development. And I thought, yeah, I can do that. I can do a roadmap. Yeah, okay. so I've done a roadmap. So this is a roadmap. Okay. And we're going to take a little trip around the roadmap. We're going to start off over here in the streams, if you like, are the goodness that comes from interoperable protocols. But people are agreeing on standards, getting interoperable, producing a platform. You can see that in the networking world here, there were various streams. Digital had their own, lots of people had their own protocols. CERN even had their own CERNnet. IBM had BitNet. There was Token Ring and Ethernet. There was these different network protocols. ISO had a scheme to bring it all together, but it kind of ran into the ground. Because the internet was what actually that IP, TCP, DNS produced this platform, this interoperable platform, which spawned many, many things. It spawned email, of course, which took off, was a great success. Apart from, as we might discuss a bit later, the only problems it ran into was spam. But many, many years later, not during the initial design, during the web years, we were all happily using email, and the internet was not used for commercial purposes. There was no spam. Other protocols, I talked a bit about Gopher hitting the mountain when University of Minnesota decided they might charge for it. HTTP avoided that mountain, and so by being paired up with HTML, which really came from, it was the HTML, the markup community, which had come from HTML was a standardization of GML, which was a generalization of all kinds of markup languages which had been produced for when people used computers for doing documentation. The idea of linking had a history going way back into the hills there. Pierre de Chardin, the French monk, dreaming of this sort of blur around the world through which mankind would communicate. In those days, he probably talked about mankind rather than humankind. Vannevar Bush, 1945, that great Memex article, imagining basically the World Wide Web, but all done with cogs and photocells and microfiche, reading rows of dots off the microfiche and feeding them to relays, which would turn the motors under the desk and produce under to the scientist's eyes the next paper in the series of links that he was reading. Ted Nelson inventing the word hypertext, proposing a system Xanadu, which was alas centralized. And, it also was designed to be the Xanadu operating company, profits largely to one Theodore Helm Nelson and friends. So there were other reasons besides architectural. There were the social reasons why the Xanadu didn't take off. But his passion for the idea of things being connected, I think, infected a lot of people. I didn't come across him. In fact, there was Wendy here at the front, an example of the member of the hypertext community at that time. There was an academic hypertext community. There was research going on around it, people doing user interface analysis and design. But it wasn't hitting the big time. It hadn't been connected to the internet. And I suppose the thing that did that was just the very simple thing of the global identifier, the URI, saying, all I said to people was like, I don't care what system you run, just keep it running, that's great. Just give everything in it a URI. I write some little program so that when I do a fetch on the URI, you send me whatever is appropriate for that URI. Okay, something, and Perl script, Rex scripts for the people with using IBMs, so IBM machines. So URIs, HTML and HTTP together produce the World Wide Web, and what of course happened was that as people started to build different browsers, they diverged. And in fact, the reason that we formed the consortium, as I said, was the danger that we would get off the track. That the danger of fragmentation, the danger we wouldn't have one web. One web is really the fundamental usefulness of the link is it can link to anything in the web, and it's got to be one web. If you draw a line down it, and half of it is in company A's web and half of it's in company B's web, then it doesn't work. So keeping it one web. There's a one web day now. I had nothing to do with it. Some day in September, I discovered people around me started celebrating and asked me to come along and join the party. It's an excellent institution. So, so each time this fragments, we have a problem. So the consortium got together and defined HTML2, and everybody was happy. But then down the line, we have the famous browser wars. So it'll cross the battle here. Microsoft and Netscape going off in different directions, and it was it was hairy there. Well, it was it in fact going to be come back together? Was it going to split? Was it going to split into one open one, and was it going to split into a proprietary one? For anybody throughout this period, that the World Wide Web seems to be, from the outside perhaps, progressing so gently down this valley of interoperable standards. There's always the temptation for a company to go and take the gravy train. The gravy train is this black line here. It goes straight. It's very fast. It takes you rapidly, and it's also very profitable. And it takes you straight into proprietary land. And because it can be very profitable to take, it's the idea that you could sell a computer. Actually, you'd give it away with cornflakes. This computer, because you'd sell a computer which had burned into an operating system, and burned into the operating system was the web browser, and burned into the web browser was the search engine you used, and burned into the search engine, because it's my search engine, is the fact that whenever you ask for shoes, then you get my shoe store. Then I sell shoes to everybody. Right? That is worth sending out the computer free in the cornflakes packets. Okay, and so that dream of being totally control one aspect of it, the web, totally control domain name, totally control delivery of internet protocol, totally control anything, you would have people foaming at the mouth and getting on the gravy train and heading towards this proprietary area. Now, I am very familiar with the open interoperable valley. The proprietary peaks, and the proprietary paths and the patent peaks tend to obscure what goes on here. We don't know so much about what goes on in this area. Little information escapes as it's patrolled by lawyers who. We understand, though, that the proprietary area is largely controlled by warlords in dark towers, such as there are rumors about the Tour of Chisholm, which is one of them, if you're into anagrams, but some people said Tolkien. This is not a Tolkien map, but some people suggest this bears some resemblance to the Tower of Sauron's evil eye. Any resemblance to Tolkien characters is completely random and has no significance. But one thing we do know is that attempting to flow out of this, for example, is the whole video industry has got the codecs that are very much in the proprietary area at the moment. Everything's patented, apart from Og and Theora, where it's not clear whether it's really these patents apply or not. Og, Theora, Ob Vorbis, and so on. So it really can affect the market hugely. It's very tempting to go into the area of proprietary control, but of course, when you do that, it really limits the market. You don't get the web effect. You don't get that explosion. Let's look, for example, let's take the case of the nomads of this in this desert here, the mobile people generating mobile technology. Then they headed off towards what they thought was a very attractive walled garden here. Attractive it was on the outside. When they got there, they found that tracking across the wasted arid plains, they found that in fact, because they had built a wall around it, no sunlight shone in there, and nothing grew. The waters, these waters of interoperability didn't flow there. Nothing was nourished. Things didn't happen. People didn't go there. It was a very arid place, and so they backed out. And very smartly, and they came to talk to W3C, and they made the next version of the wireless access protocol stack be converge with mobile X HTML, and which is just part of the HTML family and consistent, and part of the platform we see now. Mind you, many other technologies, more than one can name, have ended up in there. Some have died there. Some sit there. The walled garden is still very attractive. Anything else to remark about these? Just that there were battles around in the video. There are a lot of battles around the video area. We hear from our scouts. So meanwhile, these mountains up at the top, these hills, these are actually the foothills of philosophy. The philosophy mountains are off the map, but very much influenced by them, of course, are all the sciences and logic, and of course, and a lot of programming and lots of knowledge representation stuff, which has come out of that. The psych system, which had centralization problems, also had, but lots of interesting work has happened around knowledge representation, and which is the backing, which these things, which if you put them with URIs, produce the semantic web languages, which RDF and RDFS were produced fairly early. Now, then later, the OIL language and DAML language were sort of fused to produce the web ontology language, OWL, of course. And recently, just recently, there's a Griddle spec which explains how you can annotate marked up HTML pages or arbitrary XML documents to explain what their semantics is in terms of RDF, and the Sparkle query language has been produced, which is going to come out as a recommendation as the first thing next year. We will, as somebody said, start next year with a Sparkle. And that's going to, so we're getting some really interesting takeoff, and around there the open linked data projects, things like DBpedia, which is a linked open data form of all the data taken out of Wikipedia, all information about people and artists and tracks and places, which is in Wikipedia, is now available as data, so you can do stuff with it. And it connects to the databases, the GeoNames data, lots of websites, lots of data, sources of data are now being made available and linked together in the public so that you can do things. And they might incidentally start to become really interesting sources of data to correlate with things in, like, for example, in the reports and the disk we were given earlier that you guys produce about the internet. So what about the future? The future, there are some things we can worry about and we can get hopeful about. A lot of people are excited about virtual worlds, Second Lives and things. Some people are worried about the fact that my ISP might stop me accessing all the new video sites because they are my cable company and they wanted to be the person who decides what movies I watch this week. And there are some swamps around there, but I think we'll avoid them. The area is basically uncharted, like all the old map makers. When I didn't know what is there, I filled it in. So all these streams here are completely fictitious. We just hope that all this will go downhill. Well, there is just a natural tendency to broader interoperability, that we'll end up with a very powerful platform in the future, the sea of interoperability. What is it? Because we know that when we get that interoperability, it will tremendously, it'll improve the efficiency. It'll improve our understanding of between people. It'll understand, harmony between nations will come from people understanding each other better, and that will come from the fact that they've got technology, which is really, really cool. And by the way, I would say, we're going to talk now about web science. And I would say that if you feel that you're not a web scientist up till now, that you haven't been a computer scientist, so you haven't been involved in this sort of stuff, one of the things you have to remember now is that we're seriously thinking the web isn't all there is. That downstream, actually, that is just the beginning. Okay, there's a huge amount of stuff, and so that means that you don't have to do your work working to the web as though it is the geographical terrain, right? You can do it as though it is something which you can send back. Like undercooked beef, you can say it's okay, and I'd be very interested for you to say the web is fine, but what we really want is this. Blogs are great, but they're interesting. But what if instead we had this? You'd have to change HTTP to a peer-to-peer protocol, or you'd have to do something else. But so the technical community needs to have feedback from people who are at the other. Who are looking at maybe being frustrated by how the web is to do all this. And so that brings me to talk about how we're going to design things. This is partly how things like the web have been designed, but it's also about how we're going to do things in the future. When you compare designing the web with designing a mousetrap, with designing a mousetrap, you start off with an idea, you do some technical design, and you produce a system. You produce a mousetrap. If it is a better mousetrap than the next guy's mousetrap, you take it down to the market and you sell it. And that's it. When you design something in the web, there is, as I keep pointing out, the social side to it. The web actually has protocols like HTTP, but it's got human protocols too. There is the protocol that of kudos, the fact that in society, I like to be read. And then you combine that. So therefore, why do I make a good link from my web page to another web page, which other people find so useful? I make a link to another web page because if I link to good web pages, my web page will become valuable. And if my web page becomes valuable, it will be linked to. And if my web page is more linked to, it will become more read. And I like to be read. It all comes out of psychology. Sometimes it comes down to money. Okay, I like to be read because I get cash every time somebody does. But all the systems that we talked about, there are all kinds of internet systems. There's a long list. We might not have time to go through all of them, but they all involved a technical side and a social side. And the invention, whether people realize it or not, is often socially motivated rather than technically motivated, and there are both of those things. So when you do that, you get a system like you get some HTTP-like client-server protocol, or maybe a peer-to-peer system. But the design of the actual system just defines how people relate. The design of Wiki just says, you can edit here, be careful, don't mess with it. Go ahead. And it provides you with a really simple editor. That was the Wiki invention. But with things like the web, what's interesting is whether, of course, they take off. What is the phenomenon that actually arises? Is it good? Is it bad? The emergent phenomenon that comes from the microscopic thing. I'm always been interested in this because I did some physics way back. And in physics, you do math assuming that the room is actually full of very, very small billiard balls, all bouncing off each other completely elastically. And then when you do the sums and you imagine that somebody squashes the walls in, you find that the billiard balls speed up. And you find out that, in fact, when you do a lot of math, you find out that the properties of the billiard balls are just the same as the properties of gas. So you then propose a theory that actually the air is made of billiard balls bouncing around. And that's how physics works. And it works by finding out some little rules, whether they're quantum mechanics or classical mechanics of the micro, and then figuring out how the macroscopic world would work in that case. And the web thing has got this. And in this case, the size is the size of the web, and it's really big at the moment, right? There are about 10 to the 10 to the 11 web pages. That's about the number of neurons you have in your brain. But we don't understand the brain. We study it, though. It's complicated. We don't understand it. Things occur in the brain that we don't are kind of wonderful and splendid. The web is pretty wonderful and splendid from the things that people do in it there as well. Don't we think we should study this web? Well, we do, of course. We analyze what happens. You guys analyze what happens. You look at it. You see whether the good things correlate with this, that, or the other. And when you do that, you compare it with the things you'd like to see happening. Of course, when we look at this, we don't just analyze. We have some values. We think that we like things to be fair. We like them to be efficient. We like them to have, the certain basic rules. We like things to be democratic. We like them to be effective. We like the decisions. We like to be correct, and we like the history we write down to bear some relation to what actually happened in what we consider to be real life. So when we do this, we now do an analysis. We always end up with a shopping list of things which we would like to do. All over the place there are these shopping lists. People are staring at them. Grant funding bodies sometimes send out these lists of things they'd like cracked. We're all aware of them. And in fact, if you actually stop to think and you allow yourself to question whether the web is right, you could probably jot down a whole bunch of things you'd like to be better about the things, particularly the software you use every day on your desktop and your laptop and things very quickly. So we end up with this list of things. And when we have got this list of issues, that's when we come to the other piece, which I think is really fascinating. Then it's the other interesting spot is when somebody who's been looking at those issues for a while, they've been talking about them all week, and they go skiing, or they sit in the bath, and it's halfway down the slope. So they have that creative moment, and they have the next idea, and the wheel goes round another circle. And the creativity has always been an exciting bit for me, really fascinating. That creative moment, the fact that we do our software design in such a mechanical, mathematical way, we analyze it and we use software engineering tools, but the actual creative leap to how we're going to do the thing, or the fact that we will write the program in the first place, is done subconsciously by a mechanism which we cannot analyze. It is not provided to us. We do not have a portal. We don't have the debug access to our brain, which allows us to figure out how it was we came to it. And people are always saying, hey, when was it exactly? When did the web come to you? Where were you? They want to know the eureka moment. Actually, I'm very suspicious about the whole eureka moment idea. I don't actually, having been asked so many times for the eureka moment, having had people go away and write it up anyway, even though I had told them there wasn't one, clearly people need that story. The story is so compelling that I am pretty convinced now that, just looking at the probabilities, I feel the likelihood that the eureka moment for Archimedes is vanishingly small. That guy toiled over that program for ages. He was doing a bunch of other stuff at the other time. And some point, and he got so fed up with people saying, "When did you figure out the thing about the, with the crown and the water and all that? When did you realize?" And he said, "Well, okay, I sat in the bath and it overflowed." I say, "Okay, great, yeah." So. It's all nonsense. Creativity is really special and it's really interesting. We don't understand it. And individual creativity is very special, but group creativity, when we do things together, which is what we actually have to do to solve all these big problems, is even more interesting. And one of the reasons I wanted to make the web a big sandbox is I wanted it to be a tool for group creativity. I wanted to pool all our thoughts and brainstorming together so that we will somehow make our combined brains be slightly less stupid than our individual brains. I dream on, So you notice about this, there's two sides to it. There's the engineering side and the science side. We call it web science. We're not sure about that. As Nigel says, we're not sure about the web and we're not sure about science, but whatever. Got to call it something. But, you've got to use words. So it's got both pieces, but to me that's very important. It's not just about analyzing things. And so if you're in the business of just analyzing things, remember you should talk to the people who are building things. We've got to keep the circle rotating. We've got to keep building that list of those wish lists, because they will inspire the people who are doing the coding. And you know, there are a bunch of people looking, of geeks, who have no idea why people find the web so difficult to use, or why people find a website so difficult to use, and who are itching to find a problem to solve. They are sitting there with coding fingers already and doing random things with it until you come along and say, I have this really, and then you have to explain to them what it would look like, and then explain to them again what it would look like, and why it would be, you know, how to make it usable, and all that. But then they will be really happy to actually be useful. And so, and of course, some people have operate in many of these areas at once. But in general, I believe in this global creativity and people doing different bits and us all talking. The bit at the bottom, as I say, is magic. We don't understand what happens in this very large space of the web. We can't analyze it yet. Hopefully we should. There's some math you can do, but to actually predict that Wikipedia would that wikis would produce Wikipedia, you know, would you have honestly, if somebody had asked you when just before wikis came out, somebody said, hey, suppose there was somebody made a website which said, anybody can edit this, please be careful, it would be nice if this were an encyclopedia. Those are all the rules. You know, would that have produced an encyclopedia? You said, yeah, right. Okay, you would not have invested. You would not have been the manager who said, yes, go ahead, write it. Okay, so fortunately the person probably didn't have a manager, had a nice manager like Sandel who let him do it. So magic, there's another piece of magic, okay, where magic is the stuff you don't understand. That's what I tell my kids, is magic is the stuff you don't understand yet. And the creativity is the other part. So those are the two pieces which are really interesting. And there's a connection between them, because when you do that creative piece, when you're inventing a new web protocol, when you're inventing something which is you're hoping is going to save the world by spreading and forming something even better than the blogosphere, even better than Wikipedia, you have to second guess the collaboration of billions of people. You have to, so that there's a hunch up there, which then is held in the person's brain, and they release this thing. They put it into alpha, and they put it into beta, and they release it on the world. They release it to a few licensed, a few individuals that send in their email addresses for first, and then they release it on the world, and they tweak up the power to the server as the load increases, and they hold their breath. And this little idea, that this hunch that it might be working and be useful is sitting in the back of their brain, and they hold their breath to see whether it will actually take off. All fascinating stuff. That basically is our model for web science. And of course, it's like a lot of science and engineering, except that it's got this bit in, because it's about the web, and the web is such a big thing. We can use this model to look at a number of things. The design of the web, for example, started off with the need for collaboration. The idea was that we should have this, it was basically the idea in the proposal, the technology, URIs, HTTP, HTML. The social bit is all this stuff about link kudos, basically, that people actually, well, for physicists, it was more, if I put it on the web, people won't bug me with questions. And then later, it was, people have come to me in the corridor that I never knew and thanked me for the fact, and said that the information that I put on the web saved their weekend. So that people started to realize that actually the value add of the web is the reuse of data. It's not the use it was originally put on for. So people got the value add is the reuse in unexpected ways. So, and when they understood that, then there's more incentive. But it's all the link kudos, link love, as they call it now, I understand. I'll link to you if you link to me, because our Google comma will go up, both of us, just by making links. So that produced the World Wide Web technology, which of course produced the web explosion, and it produced all kinds of issues. Privacy, server meltdown, the fact that you can't find stuff, and the fact you can't find stuff led to, for example, search engines. The wiki, we've more or less gone around that. One of the interesting things about the wiki is for me, is phase 2. Yeah, the basic wiki produced the Wikipedia, more or less using the idea that everything was open. But actually, there were some wiki battles out there. There were some pages which were contested, which had a political element to them, a religious element to them, and the wiki didn't work for that. The rule that if I write something you don't like, you just write something on top of it, works where a whole bunch of scientists in a fairly accepted field, fairly stable field, just want to make sure that there's something really good for students, good resource for students out there. It doesn't work when you're debating something which is contentious. So the Wikipedia people have started to invent interesting social systems. And I think that one of the hopes I have for the web is that all of these many sites which are finding they're having to do this, these social networking sites, which are starting to invent new ways of actually determining how you trust friends of friends and whether it's useful to have friends of friends have different status from friends or from friends of friends of friends, and whether and sites on whether it actually would be useful if some of the networking sites allowed you to have categories of friends and distinguish friends from family, for example, or friends from colleagues. One of the things they're doing is producing new forms of democracy or new forms of meritocracy. They're trying to find out ways of of basically doing what academia we use the review process for. We get people together in committees and we give them sort of kind of status, and we have journals which have different sorts of status, and we have this strange review process which takes quite a lot of time. It's a pain. Sometimes it's really frustrating because the reviewers are so stupid, and sometimes it's frustrating because you have to read such stupid papers. But general, it kind of works, but maybe we could improve on it. And maybe out there in the web, we will end up producing new social mechanisms which will improve on the existing democratic systems that we've got today, and we'll be able to run the country better. How about that? Run the world better. Don't aim low, okay? Blogs are another interesting, the production of the blogosphere. From my point of view, one of the issues that came from the blogosphere is when my first blog, I got a whole lot of people commenting. At the time I had comments open to anybody. Lots of comments saying, hey, Tim's blogged. Yeah, he's blogged. Hey, how about that? Hey, welcome to the blogosphere. And that's I had 450 of those. And then, but then subsequent blogs are all full of Viagra ads and just one line. There was a website, the friend of a friend open social networking website had a lot of information on a wiki. And I contacted the guy who had kept it up and asked him why it wasn't up there, and he showed me the front page, which is now is offline. I started to print it off to stick it on the wall, and I had to cut it off at 19 pages. One word ads, just one word linked to Viagra sites, different words repeated again and again, completely destroying the site. No visible, actual, original content left there at all. So we've ended up now having to produce. Now we have something. We have a social network-based system. So if you want to comment on my blog, it's fine, so long as you've got an open ID, which is stored in a friend of a friend file. That's the open social networking thing, FOF. Your FOF file must have your open ID in it, and it must be pointed to by another person's friend file, back 2 or 3 clicks to somebody, the FOF file of somebody who's listed, whose FOF file is listed in the list of FOF files of people who are in our group. So basically, you've got to be 3 degrees of separation in the open social network, and then you can comment. All we really need you to know is that you're human and that you're not a bot. Okay, and the simplest way of establishing that is that you're a friend of a friend of a friend. But we're thinking about doing friend of a colleague, of a co-author, of a student who's been in a class given by somebody I played football with, whatever. There are all kinds of. One of the interesting things is using the rich semantic web network of relationships is that you can actually not just talk about closeness as you get with the web of unlinked, untyped linked, but you can really talk about the function. You can say, well, if you're a student of a class of a colleague, yeah, of course. You can, of course you're part of the community. Because we actually know, and we know, not only we've decided to trust you, we know exactly why we trust you. So you can argue about why people will do it. So here's a little bit about the semantic web. The driving issue for the semantic web was that of all the files out there, we've got the documents on the web, but we haven't got the data. The semantic web is about sharing that data. Manuel, thank you for all your data. I noticed it's in PDF. Okay, I can't put that in a spreadsheet. So one day, next time we meet, maybe one of us will have put it in RDF. So I'll be able to link it up to the Wikipedia data. Okay, so when you give me the stats about internet usage in Canada, I can actually connect it to Canada as the URI that DBpedia gives for Canada, the country, and I can connect it up to and actually compare it with the CIA factbook information and see how it correlates with your internet usage information. Okay, it's all about data sharing. Earlier we were discussing how you actually spot what's going on out there because things change so quickly. And one of the answers is you publish your data, and then other people will look at it and they'll compare it with other things, and as a community we will get much more use out of it. One of the really interesting things from the scientific point of view is the shape of the web. There's network science has, for a long time, been talking about scale-free things. Well, actually not for that long. It's fairly recent. People talked about fractal things, but it wasn't until I understand, having talked to Berners-Lee, that people had hypothesized that there were scale-free systems. But you can't really prove that something has got this power law distribution until you've got something which has got a very large scale. So it wasn't until they used the web, they went out into the web and looked at the popularity of different websites, that they had something went over several orders of magnitude, and they could show that really it seriously is a power law. And they found that when you look at the number of incoming links to a website, so the popularity link-wise of a website, you find that when you plot it against the most popular, then you plot it on a log scale, it has a downward slope of roughly gamma equals 2. So that it's a scale-free system. And so it has small world effects. So sociological, this is really important. The fact that the 6 degrees of separation that people have found in friendships, it turns out there's trying to remember the book. Actually, it's 7 degrees for the planet, 6 degrees for America. And in the web, it's 19 clicks. 19 clicks, more or less, you can get from anywhere to anywhere on the web. Nothing is more than 19 clicks from you wherever you are. 19 is more than 6, but it's still very, very small, very, very finite. The shape of the web is really, really interesting. So I think so looking at it in a fairly scientific way, that actually affects how we do engineering. It actually affects whether or not a .com will work. It affects whether the independent movie companies can set up in a garage, make movies, have them distributed and watched by more and more people, and then become a blockbuster in one smooth curve. Rather than having to at some point go and buy a cable company in order to get your movie distributed. So this long tail you've all heard of is really important, and it's so that all the math of this, there's a lot of math behind this as well. We could talk in detail about this a whole lot more, but I think that's enough. It's suffice to point out that clearly web science is very multidisciplinary. Yep, the web protocols are kind of computer science at the bottom, network engineering, but on top of it, we need awareness of all these things, because all those things affect. It's not a web of computers, it's a web of people. It's people that make links, it's people that follow links. People are affected by many things in what they do, by the policies that we should enact, maybe, and we should tweak, or we should interpret by economics. There's psychology at the base. There's large amount of mathematics about it. There's a very, very large number of disciplines around web science, and there are people in these places who are doing very things and probably don't know each other. So one of the motivations of web science is to get people in these disciplines talking to each other. And that was partly why we came today. Thanks very much for inviting us.